Did you know that not all planets have rings, and those that do, each ring tells a unique story about the planet's history? This is the fascinating world of planetary rings, cosmic jewelry that adorn only a select few in our solar system. Planetary rings are not a universal feature. In fact, only 4 planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, boast these majestic structures. Each set of rings reveals a unique tale about its host planet's past, unveiling secrets about its formation, evolution, and even potential for hosting life. From the thick, icy rings of Saturn to the thin, dark rings of Uranus, these cosmic bands are as diverse as the planets they encircle. They are silent storytellers waiting for us to decode their hidden narratives. So buckle up as we uncover 10 astonishing insights from studying these cosmic ornaments. Starting at number 10, the composition of these rings isn't as simple as you might think. Planetary rings, like those we see around Saturn or Jupiter, are primarily made of ice, but that's only part of the story. These icy structures are often laced with dust particles, giving the rings their ethereal glow as they catch the sunlight. But wait, there's more. Embedded within these rings, there can also be larger chunks of rock, remnants from asteroids or comets that got too close and were torn apart by the planet's gravitational pull. And it doesn't stop there. Scientists have detected traces of other elements too. Carbon, nitrogen, oxygen, ingredients essential for life as we know it. These elements are likely trapped within the ice and dust particles, locked away until some future event might release them. They are a fascinating mix of elements, each telling a different chapter of the planet's story. At number 9, we have the dynamic nature of these rings. The rings of planets are not static entities, frozen in time. Instead, they are vibrant, constantly changing and evolving. Imagine a bustling city with traffic flowing in all directions. Now replace the cars with ice particles, dust, and rocks, and you've got a pretty good idea of what's happening in these planetary rings. The rings are always in motion, interacting with their host planet and moons, creating a celestial dance that is both complex and breathtaking. This constant motion and change are driven by the forces of gravity, pulling and tugging at each particle in the ring. As these particles collide, break apart, and reform, the rings continually reshape themselves, creating a visual spectacle that is a testament to the dynamism of our universe. The dynamics of these rings are a cosmic ballet, choreographed by the forces of gravity. Moon formation is our 8th insight into the study of planetary rings. You see, these rings are not just decorative bands of ice and rock orbiting planets. They are, in fact, the birthplaces of moons. Yes, you heard that right. Planetary rings can give birth to moons. Now, how does this happen? Well, over time, the particles within these rings can begin to clump together due to their mutual gravitational attraction. As these clumps gather more and more material, they can grow into moonlets and eventually full-fledged moons. Several moons within our own solar system likely originated from rings. Saturn's moon Rhea, for example, is believed to have been born out of the planet's rings, and it's not alone. Many other moons may owe their existence to these celestial bands. Rings, it seems, are celestial nurseries cradling moons into existence. Our 7th insight is about the age of these rings. Unraveling the age of planetary rings is no easy task. Scientists often rely on a combination of techniques, including measuring the rate of dust accumulation and studying the rate of change in ring particles' orbits. The age of these rings can tell us a lot about the history of our solar system. For instance, the youthful rings of Saturn, estimated to be just 100 million years old, suggest a relatively recent event, perhaps a collision or a breakup of a moon. On the other hand, the ancient rings of Uranus, believed to be as old as the planet itself, offer a glimpse into the early solar system, a time of chaos and construction. By studying these rings, scientists are essentially reading a cosmic diary, each page filled with tales of astronomical events and transformation. The rings are silent witnesses to the past, holding secrets of our solar system's youth. The 6th insight is the surprising thinness of these rings. While planetary rings like Saturn stretch out for tens of thousands of kilometers, their thickness measures a mere tens of meters. Imagine a sheet of paper, wide and long but incredibly thin. This is a quite accurate comparison to the thinness of these rings in relation to their size. The thinness of the rings gives us clues about their formation and stability. The process that formed them must have been delicate and precise, likely involving finely balanced gravitational forces. It's a process that, despite our best efforts, still holds many secrets. The thinness also speaks to the rings' stability. Despite their expansive size, they remain stable and intact, a testament to the delicate balance of forces at play. These forces include the gravity of the planet they encircle, the gravity of the ring particles themselves, and the centrifugal force caused by their rotation. Despite their impressive span, these rings are wafer-thin, a delicate balance maintained by gravity. Our fifth insight takes us to the gaps in these rings. A first glance might suggest that these gaps are voids, empty spaces in the ring's structure. But that's far from the truth. The gaps are actually vibrant arenas of celestial interactions. The primary reason behind these gaps is the gravitational interactions with nearby moons. These moons, even though they might be small, have a significant pull on the surrounding ring particles. This interaction over time results in the creation of these gaps, an intriguing dance of gravity in action. But that's not the only force at play. The gaps can also be a result of resonances with the planet's magnetic field. The magnetic field, invisible to the naked eye, can influence the motion of charged particles within the rings, leading to the formation of these gaps. So the next time you look at these gaps, remember, they are not empty but filled with tales of celestial interactions. The fourth insight is the captivating colors of these rings. Now, these cosmic bands aren't just fascinating for their shape and size, but also for their varying hues. The color palette of planetary rings ranges from dusty rose to icy blue, with each color narrating a unique tale of the ring's composition, origin, and evolution. The hues are influenced by the ring's composition. For instance, Saturn's rings, primarily made up of ice particles, appear bright and almost white due to their high reflectivity. On the other hand, the reddish-brown tint of Uranus's rings is attributed to the presence of organic compounds known as tholins. The colors also provide clues about the ring's past. Rings with a higher concentration of reddish particles indicate a longer exposure to cosmic radiation and solar wind, suggesting a greater age. In essence, the colors of the rings are not just beautiful to look at, but they also tell stories of their past. The third insight is about the particles that make up these rings. Imagine a world of tiny dust grains and colossal icebergs, all swirling together in a cosmic ballet. These aren't just any particles, they are the architects of the rings we see. Each particle, regardless of its size, plays a crucial role in shaping the rings. The tiny dust grains, barely visible to the naked eye, often clump together, creating more substantial formations that contribute to the ring's overall structure. On the other hand, the iceberg-sized particles, with their immense mass, help maintain the ring's stability and shape through their gravitational influence. It's a spectacular show of unity and diversity, with each particle, big or small, contributing its bit to the grand scheme of things. This is a perfect example of how even the smallest elements, when working together, can create something truly majestic and awe-inspiring. The rings are a cosmic sea of particles, each playing its part in the grand design. Our penultimate insight is about how these rings came into existence. Understanding ring formation is like piecing together an epic cosmic puzzle. One popular theory suggests that these rings are remnants from the early days of the planets, left over after their formation. A sort of cosmic dust that never coalesced into moons or other bodies, instead forming these majestic rings. Another theory posits that the rings could be the result of a cataclysmic event, such as a moon or comet straying too close to the planet and being torn apart by its gravity. This destructive process, known as tidal disruption, could have scattered debris into orbit around the planet, eventually forming a ring. Yet another possibility is that the rings might have been formed from captured interstellar objects like comets, which were ripped apart and spread out around the planet. Regardless of their origin, the birth of these rings is a tale of cosmic destruction and creation. And finally, our number one insight is about the future of these rings. The longevity of planetary rings is a hot topic in the world of astronomy. The consensus? These beautiful celestial structures are not eternal. Over time, the gravitational pull of their parent planets will gradually draw ring particles inward, causing them to fall into the planet. This process, often referred to as ring rain, is a slow but inevitable fate for these cosmic bands. Yet, even as ring particles are lost, new ones can form. Collisions between moons or the capture of passing asteroids can generate fresh material to replenish the rings. Furthermore, under the right conditions, these particles can coalesce to form new moons, ensuring the continued dynamism of these systems. The future of these rings is as fascinating as their past, a never-ending cycle of cosmic evolution. So, there you have it. 10 mind-blowing insights about planetary rings. Each one of these insights has contributed to our understanding of these magnificent celestial bodies and their roles in the cosmos. Let's take a moment to reflect and appreciate what we've learned. We've delved into the composition of these rings, discovering that they're made up of everything from tiny dust particles to massive boulders, each playing a part in the grand cosmic ballet. We've explored the dynamics of these rings, understanding how gravitational forces and collisions shape and mold them into the breathtaking structures we see today. We've also looked at how rings can act as cradles for moon formation, a process that has likely given birth to countless moons throughout our solar system. We've pondered the age of these rings, a topic that is still a subject of ongoing research and debate among scientists. We've marveled at the astounding thinness of these rings, a stark contrast to their vast radial extent. We've navigated through the gaps in the rings, areas devoid of material that tell a story of moons and resonances. We've admired the array of colors in the rings, hues that reveal the varied composition of ring material. We've studied the particles that make up these rings, each one a tiny world in its own right. And we've pondered the formation of these rings, a process that is as beautiful as it is complex. Each of these insights changes the way we look at the planets in our solar system. No longer are they just isolated globes floating in the void of space. They are complex systems, each with its own family of rings and moons, each telling its own unique story of cosmic evolution. In the grand tapestry of the cosmos, the rings are but a thread, yet they hold profound insights into the workings of our universe. They remind us of the beauty and complexity inherent in nature and inspire us to keep exploring, to keep asking questions, to keep seeking answers, because in the end, that is what science is all about. If you've learned something new from this video, or even just enjoyed our journey through the cosmos, then please give this video a like. Your support goes a long way in helping us continue to explore and understand the universe. And don't forget to share your thoughts and opinions in the comments below. We'd love to hear what you think about the mysteries and wonders of planetary rings. If you haven't subscribed yet, now's the time to do so, and press that bell icon so you never miss an update from us. We have a lot more fascinating content in the pipeline, and we're excited to share it with you. And lastly, if you think your friends or family would enjoy this video, don't hesitate to share it with them. After all, the beauty of the cosmos is best appreciated when it's shared. Thank you for joining us on this journey, and we look forward to seeing you in the next video.